Welcome back. I hope you all are doing well. In our earlier series of lectures, there we have already learned about rational numbers and its various properties and arithmetic operations. We also solved various types of exercises based on rational numbers, and we also answered objective type questions. Today I will start a new module which is based on powers and exponents. Though powers and exponents are not a very new thing to you, first we will get introduced to powers and exponents, then we will see the different laws of positive integral exponents. We will solve various exercises based on them. Then slowly we will move to negative integral exponents. We will also learn about different laws related to that. We will also simplify relevant exercises on that. Then we will also continue with various types of objective type of questions. So let's get started. Suppose we have a non-zero rational number a and we want to multiply that rational number by the same number, say another a. So what will be the result? We write that as a to the power 2. Now suppose again if we want to multiply a by the same a, so how we will write this? It will be a to the power 3. Now suppose we multiply a 4 times, then how it will be written? It will be a to the power 4. Now suppose if we multiply a by the same number a n times, then how it will be written? It will be a to the power n, where a is called base and it is a non-zero, we know, rational number, and n is called exponent and n is natural number. So this is defined or pronounced as a raised to the power n, or sometimes we in short pronounce as a to the power n, and this is also we call as nth power of a. Next we will learn about various laws of positive integral exponents. The first law says that suppose we have base a and if we have two exponents m and n, where a is a non-zero rational number and m and n both are natural number, that means from 0 to theoretically infinity. So if a to the power m is multiplied by a to the power n, then the result can be written as a to the power m plus n. So in this multiplication, base same and exponents are different. Now let's understand this with an example. Let's have the base value as 2 and exponents as say m as 2 and let's have n value as 3. That means first we will find the value a to the power m. So it will be 2 to the power 2, m value is 2, so it will be 4. And then separately we will find the value of a to the power n. Again a is 2 and n is 3, so it will be 8. And left hand side of that law, which is a to the power m, which is 4 in our case, multiplied by a to the power n, which is 8 in our case, that will be 4 8s are 32. Now let's come to the right hand side of that law. Right hand side, what it has? It has a to the power m plus n. Here a is 2, the same base, and m and n, what are the values? 2 plus 3. So it will be 2 to the power 5. 2 to the power 5 means what? 2 will be multiplied by the same number, which is 2 5 times. So it will be 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. That means On the left hand side we have the value, we obtained the value 32, and on the right hand side also we obtained the value 32. Hence this law is satisfied for any non-zero rational number as base, and any exponent value should have different value. Even if m and n have same values, then also it will be applicable. Like if suppose we multiply 2 to the power 2 with 2 to the power 2 again, then as per law it will be 2 to the power 2 plus 2 means 4. So it will be 2 to the power 4, that means it will be 16. And separately if we assess the left hand side, it will be 4 and it will be another 4, so it will be 16 also. So it's not mandatory that m and n has to be, they have to be different always. This is applicable for same exponents as well, but generally or mostly this will be applicable when m and n will have different value. Now we will move on to the next law. Next law says, suppose if we have again the same base a, and if we take mth power of that base a, that means a to the power m, and if we divide that factor by nth power of the same base where a is non-zero rational number, then that result will be nothing but a to the power m minus n. So initially in the first law what we learned was when we multiply them, both the factors where the exponents or powers are different, then we basically add those powers or exponents. And when we divide those two factors where the exponents are different for the same base, then basically we subtract one exponent from the other. Here m will be greater than n. Now let's understand this with an example. Again, if we take base as 2 and exponents, this time since m has to be more than n, so let's take m3 and n2. So separately if we evaluate them, then a to the power m will be 2 to the power 3, so it will be 8. And separately if we evaluate a to the power n, then it will be 2 to the power 2, that means it will be 4. So left hand side will be a to the power m divided by a to the power n, that means 8 divided by 4, so it will be 2. And what we have on the right hand side of this law says this should be equal to a to the power m minus n. So let's see what we will be getting. So a, the base is again 2, m is 3 and n is 2, so it will be 2 to the power 1. 2 to the power 1 means 2 only. That means from the left hand side we obtained 2 and from the right hand side we also obtained 2. So this law is satisfied. Now in the beginning I said that m has to be greater than n. But what happens if m is less than n? So here a to the power m divided by a to the power n, a to the power m minus n. Now if suppose m is less than n, then what will happen? If m is less than n, then this exponent will be negative exponent. I will discuss about negative exponent in my upcoming class, and then there also we will be solving exercises. But here I am giving you a brief idea. So how it will be written is, since m is less, so minus 1 we will be taken common, so it will be written as n minus of n minus m. Now a to the power minus n, where n is the negative exponent, is basically reciprocal of the a to the power n. That means the factor what has positive exponent. So here also, since a to the power minus of n minus m, so it will be take the whole thing, the whole power or exponent will be taken as negative exponent. So it will be finally considered or taken as 1 divided by a to the power n minus m. Now suppose if in the real example, suppose we are dividing 2 to the power 2 by 2 to the power 3. So it will be 2 to the power 2 minus 3, and 2 to the power 2 minus 3 means 2 to the power minus 1. That means it will be 1 divided by 2 to the power 1. So it will be half only. And separately if we assess this, then 2 to the power 2 means it will be 4, and in the denominator 2 to the power 3 means 8, and 4 divided by 8 means 1 by 2 only. So this concept we will be again learning in our future class. Now we will learn the next law of positive integral exponents. The next law, or third law, it says, suppose we have a base a, and if we take mth power of that base, and whatever result we will be getting, and if we take nth power of that result, then it will be equal to a to the power m multiplied by n. Now we will understand this in a better way with an example. Again we will take the same base. If we take, so a will be equal to 2. Again if we take the value of m as 2 and value of n as 3. Now the left hand side, what it says that first we will take a to the power m. A to the power m means what? A is 2, m is 2, so it will be 4. Then whatever result we will be getting, then we will take nth power of that result. That means here it will be 4 to the power n value is 3. So n value is 3 means what? 4 multiplied by 4 multiplied by 4. Here the power is 3, that means we are multiplying 4 by the same number 3 times. So here it will be 4 4s are 16 and 16 4s are 64. Now we will evaluate the right hand side of this law. Right hand side says a to the power m multiplied by n. So here a is 2 and value of m is 2 and n is 3. So it will be 2 to the power 3 2s are 6. So it will be 2 will be multiplied by 2 6 times. 6 times means 2 2s are 4, 2s are 8, 2s are 16, 16 2s are 32, 32s are 64. So from the left hand side we obtain 64, and from the right hand side also we obtain 64. So we can use this law wherever we need to use. Now this is for a to the power m and then to the power n. But this is also applicable when we first take the power n of the same base, and then of that result if we take the power m, we will be getting the same result, a to the power. Basically we can think this way, n multiplied by m, and if it is mn or whether it is nm, that will give us the same result only. So it can be written as again m multiplied by n. So whether we are taking the m first and then we are taking the nth power, that will be same as, the result will be same as even if we take the nth power first and then with of that result if we take the mth power. So we have to remember this also. And here we don't have any condition that m has to be greater than n, or n has to be greater than m, or maybe m is equal to n. This is applicable for all these conditions. Next we will learn the next law, the fourth law of positive integral exponent. So far we took single base, one base, and we took different exponents. This time we will be taking different bases. So we will take two bases, base a and b, and we will be taking same exponents or single exponent, and that suppose if we take m. Then this law says that if we first multiply the bases, so a multiplied by b, and then of that result if we take the power, then that will be equal to a to the power m multiplied by b to the power m. Now let's understand this with again a real example. Suppose if we take a as 2, if we take b as 3, and if we choose the exponent m say as 4, then the left hand side of this law if we evaluate, then what we will get? we will do this way. First the bases will be multiplied. So here a b to the power m. That means the base 2 will be multiplied with the base 3, and then of that result we will take mth power. So here this time it is 4. So it will be 2 and 3, it will be 6 to the power 4. 6 to the power 4 means it will be 6 multiplied by 6 multiplied by 6 multiplied by 6. That means here it will be 6 are 36 and 6 are 36. So it will be 1296, 1296. Now let's evaluate the right hand side of this law. Right hand side says that it will be a to the power m, and then it will be multiplied by b to the power m. So a to the power m means a is 2 and m is 4, and b we have taken as 3 and m is same value m has. Then 2 to the power 4 means what? 2 will be multiplied by the same number, it will be multiplied by itself 4 times. So it will be 2 twos are 4, 4 twos are 8, 8 twos are 16. Similarly, here 3 will be multiplied by itself 4 times. So it will be 3 threes are means 9 and 3 threes are means 9. So 9 multiplied by 9, it will be 81. So here we will multiply 16 by 81, and if we multiply 16 by 81, we will be getting 1296. So from the left hand side we are getting 1296, and from the right hand side also we are getting the same value, same result. That means we can also use this law wherever is required. Now we will move on to the next law, which says that if we have different bases, say a and b, and if we first divide them, in the previous law what we did, we multiplied those two bases and then of that result we took the power. This time we are dividing those two bases and then of that result we are taking the powers. And what it will be, I believe that you have already guessed that what it will be. It will be a to the power m divided by b to the power m, because in the previous law what we learned was it was multiplication of both the factors. This time it will be division of both the factors. Now let's again learn this with an example. Now suppose if we take the value of a as 4, value of b as 2, and the value of m as say again 2. So from the left hand side what we will be getting, from the left hand side the law says it will be a divided by b and then power of that result. So it will be a is 4, b is 2, and then to the power 2. The value of m we have chosen 2. So it will be, first we will divide these two bases, then 4 divided by 2 means 2, and then 2 to the power 2. So it will be 4. And now separately if we evaluate the right hand side, then it will be a to the power m divided by b to the power m. A to the power m means a is 4 and power is 2, and divided by b is 2 and then power is also 2. 4 to the power 2, that means 4 will be multiplied by itself twice. So it will be 4 4s are, so in the numerator 4 4s are 16, and in the denominator we have 4. So finally it will be 4 only. So from the left hand side we obtained 4, from the right hand side also we obtained 4. That means this proves this law. Now we have another law, and this law says that in the beginning I said that this is nth power of n, where a is non-zero rational number and n is a natural number, and we know that natural number starts from 1 and then it continues, gradually it increases, and theoretically it can continue till infinity. So this is true for any natural number, and we know that with natural number if we add 0 then that becomes a whole number. If suppose the exponent value is 0, that means if n is equal to 0, then it will be a to the power 0, and a to the power 0 is always 1. So whatever the base is, if the exponent is or the index value is 0, then the result will be always 1. So if the base is 2, it will be 1. If the base is 20 and the exponent or index is 0, then it will be 1. If the base is 4000 but the exponent is 0, then also it will be 1 only. You can think this as per the second law that we learned, that a to the power m divided by a to the power n is equal to a to the power m minus n. So if we use this law in reverse order, that means a to the power m minus n, and here if we choose m and n both are equal, then what it will be? In place of n we can write m again, because m and n we have chosen same. So it will be what? It will be a to the power 0, and a to the power 0 means what? From the left hand side we know from the second law that it will be a to the power m divided by a to the power n, and a to the power m and again a to the power n. N means in place of n we can write a to the power m, and a to the power m and n to the power m, since we have the same factor, same value in the numerator and denominator, then they will cancel each other and finally we will be having 1 only. So whatever base we have, if the exponent or index value is 0, then the final value will be always 1. So this is a special type of law we can say. That means as I said in the beginning that this is applicable for any natural number, this exponent or index, this n value, but this is also true for whole number also. That means this is also true for 0 as well. If the exponent or index value is 0, then also we can apply. Again, we should know that if the base is a and if the exponent or index value is 1, then it will be always a only, and we don't need any separate explanation or proof for this. So exponent or index value, if it is 1, then that means we are multiplying that base only once, so it will be that base value only. So this was the whole explanation of positive integral exponents and its various laws that we use to simplify different problems. In the next class we will be learning about negative integral exponent. Till then, stay safe and stay healthy. Thank you.